Today we learn the negation of compound statement. You know that there are 5 connectives and each connective has its own rule of negation. What are these rules? Let's have a look. First is negation of conjunction. It is negation of P and Q is equivalent to negation of P or negation Q. The second one is negation of disjunction. The rule is negation of P or Q is equivalent to negation of P and negation Q. Here and is replaced by or and or is replaced by and. The next rule is negation of implication. It is negation of P implies Q is equivalent to P and not Q. The next is negation of double implication. The rule is negation of P double implication Q is equivalent to P and not Q or Q and not Q. Listen one thing, that negation of negation is the statement itself. These are the rules. Now consider example. Suppose 2 is an even number and 3 is an odd number. We are to find the negation of this compound statement. Now here the connective is and, so we are to follow the rule of negation of conjunction. So by this rule the negation will 2 is not an even number or 3 is not an odd number. This is the negation of conjunction. Now consider negation of disjunction. Next example. Suppose you are given statement as 2 is an even number or 3 is an odd number. You are to find the negation of this statement. Then here the connective is or, and by the rule of negation of disjunction the negation will 2 is not an even number and 3 is not an odd number. This is the negation of disjunction. The next is negation of implication. Consider example. If 2 is an even number, then 3 is an odd number. Here the connective is if then, so we are to follow the negation of implication. The rule will, the statement will 2 is an even number and 3 is not an odd number, because the rule is P and not Q. The last is negation of double implication. Consider example 2 is, if 2 is an even number is an even number, if and only if 3 is an odd number. The example is 2 is an even number if and only if 3 is an odd number. Now P is the statement is written as in symbolic form. Negation of P double implication Q is equal to P and not Q or Q and not P. The symbolic form of this negation will 2 is an even number and 3 is not an odd number, or 3 is an odd number and 2 is not an even number. This is the negation of double implication. Now If statement has all, then it is replaced by some, and if statement has some, then it is replaced by all. Consider this example. All equilateral triangles are all scalene triangles are equilateral triangles. Consider this example. Then its negation will be some scalene triangles are not equilateral triangles. Some scalene triangles are not equilateral triangles. Here we replace some by all. Next example, all natural numbers are real numbers. Then its negation will some natural numbers are not real numbers. Again, one more example, some odd numbers are natural numbers. Then its negation will all natural numbers are not real numbers. Again, the next topic is negation of quantified statements. Now, there are two types of quantifiers. First is universal quantifier, which is denoted by this symbol, universal quantifier. First is universal quantifier and second one is First is universal quantifier and second is existential quantifier. The statement which contains this quantifier is called quantified statement. So let's learn how to find the negation of this quantified statement. Example, for all n belonging to n plus 7 is less than or equals to 10. This is the example. It is written that for all n belonging to n plus 7 is less than or equals to 10. Then we are to replace this universal quantifier by existential quantifier. So negation will there exists n belonging to n such that n plus 7 is not less than or equals to 10. This is the negation of given statement. Then second example, consider there exists n belonging to whole number such that n plus 3 equals to 5. Such that there is negation. Then its negation will for all n belonging to whole numbers, comma n plus 3 not equals to 5. This is the negation of given second statement. So that's all about the negation of compound statement. Do practice the given exercise positively. Thank you very much.